All right, guys. So here's 5-4. This one is solving systems of equations by using elimination. So we're going to go through a handful of practice problems here. I think there's only 5. Yeah, we're going to go through 5 practice problems here. And I'm going to go through every single one of them. And hopefully by the end of this, you'll be able to know how to manipulate some equations and be able to solve systems of equations using elimination rather than having to use substitution or having to use, a graphing calculator. And if that's not available to you on a test or a standardized test, well, that's probably your best bet is to probably use elimination and or learn how to do substitution. So here we go. So number 1 says solve the systems of equation using elimination. So we have these two equations right here. This first one is 2x minus 7y equals negative 13. And the other one says 8x minus 7y equals 11. So the purpose here of this is to solve for either x or for y, or both. So the first step is to look at your x values and look at your y values and to see if any one of these are the exact opposite of each other. So for instance, you got a 2x and an 8x. Those are not opposites. Negative 7y and a negative 7y, those are the same, but they're not opposites. So this is probably what I'm going to be looking at here on this particular problem. And then the top one equals negative 13, the other one equals 11. So it says multiply the second equation by a certain number. So if you think real hard, what could I multiply this whole equation by to make it be the opposite of this guy right here, in particular this negative 7y. So what number, the way I'd be thinking about it is, what number could I multiply a negative 7y by in order to make this one a positive 7y, because that's what I need it to look like. Well, hopefully you answered a negative 1, or in this case, you may not know right off the bat, and that's okay. So multiply the second equation by negative 1. So what you would do is you would multiply both sides of the equation by negative 1. And if I do that, then I would get negative 1 would have to get distributed into here. And then I would end up with a new equation that would say negative 8x plus 7y equals negative 11. And now that I did that, I have this equation and this equation, which is what they wrote right down here at the bottom. So they have those two equations written out, and they're stacked on top of each other. So then you can literally make it into one big equation if you just combine the two. So if you combine the two, then that'll be, you have this 2x take away 8x. So 2x take away 8x, that'll give you negative 6x. And then you have a negative 7y plus 7y. So if you put these two guys together, they actually cancel each other out, which is what we want. And you end up with 0y. And then you have this negative 13 minus 11. So negative 13 minus 11. And that'll give you negative 25. Or 24, I'm sorry, 24. All right, so since this guy right here is technically 0y, it's not even needed. So that you can technically just don't even need, but they put a placeholder there just for you to understand the concept. So really this equation says negative 6x equals negative 24. And then all you have to do is solve for x. And it's just a one-step equation where you divide both sides by negative 6. And then you would get x is equal to 6, 12, 18, 24. You get 4. So the solution is x equals 4 and y equals blank. So in order to solve for y, we need to take this information that we know about x and plug it in for x wherever we see an x in the equation. So if I plug in a 4 right here, I can then solve for letter y, which we should be fairly prepared to do this just because we've been doing this on substitution for a very long time. If you go back and watch that video, you see that we actually did this. So whenever we actually solve for a letter, we take that letter that we now know is a number and plug it back into the other one to solve for the other missing variable. So there shouldn't be hopefully anything new. So 8 times 4 is 32. And then we got minus 7y equals 11. So from here, what you would do is you would subtract 32 from both sides. So subtract 32, subtract 32. That would cancel. And you have 11 take away 32. And that'll give you a negative 21. Excuse me. And then from here, you would divide by negative 7 on both sides. And you would get y is equal to 3. And you're all done. So I think this one's a lot easier than substitution. I think obviously the easiest way is to graph and then look at the graph. And if you can interpret the graph, well, that's basically the same thing. So for instance, you can go graph these two equations that we had in the very beginning on this problem. You can graph both of them in the Desmos graphing calculator, and then you would notice that they would cross or intersect at the coordinate point 4, 3. 4, 3 is where they would intersect on a graph. And that's how you would do solving systems using elimination. At least there's a practice problem with some fill in the blanks. And sometimes you don't even need to multiply. Like for instance, up here, we had to multiply both sides by -1 so that we could have an opposite like this, so it would cancel out. Sometimes you don't even have to do that. Sometimes the problem is already built in your favor. So for instance, number 2 says solve the system of equation using elimination. Well, if you look at this equation, our x's right here, they're already opposites of each other. This is 7x and this is -7x, so these are opposites. So I technically can just go ahead and start. I don't need to multiply any equation by any number. I can just go ahead and rock and roll. So if I do that, I would get 7x and then the minus 7x, those cancel. And then 2y plus y, that gives me 3y. And then you have a negative 13 plus 25, or a negative 13 and a 25. And if you put those two together, that should give you a positive 12. And then from there, you just divide by 3. And it's a done deal. Y would be equal to 4. And now that you know that y is equal to 4, now you just got to use that information to help you figure out what x is. So let's just use the top equation here. We would have 7 and then 7x and then plus 2. And then in parentheses for our y, we know it's 4. And then we can solve for x. So we have 7x plus 8, because 2 times 4 is 8, and it equals 13. You subtract 8 from both sides of the equation to solve for x. You get 7x is equal to, I believe that's -21. And the last step would be to divide by 7. You get x is equal to -3. And you're all done. So a lot less work than the average substitution problem. So if you have two equations that can be stacked on top of each other to where they basically have everything on the left side and then just a number on the right side, you can use this method relatively pretty efficiently, and it kind of cancels stuff out, and you can kind of move a little bit faster. So this is a pretty good tool to have in your back pocket. All right, so that was number 2. Let's go look at number 3, because number 3 looks pretty wild. So let's hopefully I can take this and kind of minimize it a little bit. There we go. All right, so solve the system of equation elimination number 3. So if I'm looking at this equation, I got 2x plus 5y equals -23. And this one's 5x plus 13y equals -60. Now, if I'm looking at my x's and I'm looking at my y's, neither one of those are opposites of each other. So this problem is actually going to be relatively difficult, just because we're going to have to make 2 new equations to finally be able to get our x's or our y's to be the exact opposites of each other. So what I would possibly do for this one is, and this is where we have to know our multiplication facts and least common denominators and stuff like that. So I would in particular probably look at this 2x and this 5x and try to get them to become opposites of each other. So what I would do in this particular, so just watch this particular part. So what I would do is I would multiply this top one by probably -5, and then multiply this bottom one by a +2. And if you do that, you'll see that the top equation, our x values will become, at least on the top, would become a -10x, and on the bottom you'd have a +10x. And then those are opposites of each other, so then therefore they'll cancel each other out. Okay, so the top equation, this top one right here that I'm about to highlight in, let's just say this weird looking color here. This top one here, let's go ahead and write it right here. So we have this -5 times 2x, that'll give you a -10x. And then the -5 times the 5y should give you a -25y. And then the -5 times 23, well, that's a doozy. So that'd be, let's see here, 23 times the 5. 5 times that's 15, carry, 10, 11. It's 115, and it's a negative times a negative, so it is going to be a positive answer. So it equals 115. Now for the second equation, we need to multiply it by that +2. So let's highlight that one in. I think this is purple. And we're going to take that one and write it right here. So that'll be 2 times 5x, which that'll become a +10x. And then 2 times 13 will be a +26. And then 2 times 60 is a -120. And now I have these two equations, these two new equations that still represent the same information as the one before, or at least the two before, because we just scaled them up. We scaled the top one up by -5 by multiplying everything by a multiple of -5. And then we did the same thing with the bottom equation, except we did it with a +2. And if you do that, hopefully you'll notice and realize that your x values right here, these x values, they are opposites of each other. And if they're opposites of each other, they can be crossed out, and we don't need them no more. So if I do that, I end up with this being crossed out. -25y plus 26y is just 1y. And then 115 and a -120 will give you a -5. And, well, lo and behold, we figured out what letter y is. There's no reason to keep going because y is equal to -5. There's no number in front of letter y except an imaginary 1, which is fine. You can have that. Okay, so y is equal to -5. Now all we have to do is take this information here and plug it in to one of the equations. In my opinion, I'd probably choose the easier one, which is probably the one in, I think it's like that pinkish looking color we used. I think it was this one here. So let's take and plug this information in right here into this top equation right here before we multiplied it out. So if we do that, we would have 2x plus 5y, but that y, we know it to be a -5, and it's going to be equal to -23. And I just need to solve for x. So I have 2x minus 25, because a +5 times a -5 is a -25, and equals -23. Now that we're here, it's a two-step equation from here. We need to solve for x, and in order to do that, we need to add 25 to both sides using inverse operations. 2x comes on down. And negative 23 plus 25 is a positive 2. Last step, you guessed it, and divide by 2. And you get x is equal to 1. So you got x is equal to 1 and y is equal to negative 5. And you're all done with that problem. So that's pretty difficult. That one you'd have to actually multiply some numbers on the first equation and the second equation just to get them to make them look like each other. And remember, the goal is always to make either the x's or the y's become opposites of each other. That's the whole goal, so that they can cancel out and you don't have them no more. Then the equation becomes relatively easy. So let's go look at these last two problems. We got a balloon problem and a reasoning problem, and then we'll be done. So it says, excuse me, two balloons, balloon A and balloon B, have a total volume of 3 3/5 gallon. Balloon A is greater than the volume than balloon B. The difference of their volumes is 1/5 gallon. Write and solve a system of equations using elimination to find the volume of each balloon. Okay, it's not very bad. So you have to write two equations. Now this is relatively difficult. Hopefully you don't have problems that make you write the equations, but if you do, that's okay. So if we look at this story, we have balloon A and balloon B, and they have a total volume of 3/5 gallons. So that means I would add those two balloons' volumes together, and it would be 3/5 gallons. So you have balloon A plus balloon B, and it would equal 3/5. And that's how you would do that first equation for this problem. The next sentence right after the first one says balloon A has a greater volume than balloon B, and the difference of their volumes is 1/5 gallon. So that means volume A, take away volume the balloon of B, it would give you 1/5 of a difference. And there's your two equations. And it says write and solve a system of equations using elimination to find the volume of each balloon. So here we go. We have two equations. And if you notice, there actually is already opposites of each other in this particular case. We have a positive letter B, and we also have a negative B in the other one. Those are opposites of each other. So if that's the case, I can put these together. A and A gives me 2A. These guys would cancel, and I'd have 3/5 plus 1/5, which gives me 4/5. And now I can solve for letter A. All I gotta do is divide by 2 on both sides, and I get A is equal to 4/5 cut in half should give you 2/5. And just in case you don't know how to do that, you can go to a calculator and do 4/5 divided by 2. So let's go double check. Let me make sure I did my math right. So we got the 2/5. Oh, I forgot to use this. Alpha y equals. So we got 2. Or I'm sorry, it was 4/5. 4/5 divided by 2. And that gives you 0.4. So if you hit math, enter, that gives you the 2/5. So you got 2/5 for an answer. Exactly what I have right here. So the balloon A has 2/5 volume. And it says that if I add the two together, I would have 3/5. So let's look at this top equation here. You can pick either one, doesn't matter. I just like to use the one that has addition on it just because it's easier to mess with, because I don't necessarily like negative numbers, but I don't know about you. But letter B is negative on the second equation. So let's look at this first one. So you have A plus B equals 3/5. And I know that letter A down here is 2/5. And this is all equal to 3/5. So to solve for letter B, I would subtract 2/5 from both sides. And I would get letter B is equal to 1/5. And you can go to the calculator. You're more than welcome to go to the calculator. Do 3/5 minus 2 over 5. So 3/5 minus 2/5. And if you subtract those in the calculator, you'll get 1/5. So balloon A has a volume of 2/5, and balloon B has a volume of 1/5. And then you're all done. And that's number 4. All right, let's go to number 5. It says reasoning. So it says, let's go with Sunny. Sunny needs to solve the system of equations using elimination. What variable should Sunny solve for first? Well, if I was Sunny, and hopefully you can kind of put yourself in the shoes as well, or hers, him, them, they. Sunny here, we got this first equation, we got this second equation. Hopefully you guys notice by now that we're looking at our x and our y values to see which one of them are opposites of each other, and if they are, then those would technically eliminate, and if there is nothing that is exact opposites of each other, then we would have to manipulate one or both of the equations via multiplication to be able to get something that is the opposite of each other. However, in this case, thankfully our y's are exact opposites of each other. The top one is a positive 3y and the bottom one is a negative 3y. So these are exact opposites of each other, which is awesome. So it says, which variable should Sunny solve for first? Well, if my y's are exact opposites of each other and they're going to cancel out, that means I would end up solving for letter x first. So solve for x. First. And I would say because my y values would cancel out. And then therefore I would have only x's because my y values are already exact opposites of each other. So if I combine those two equations together to make one equation, shazam, my y's will be gone. And now it says, well, find the solution. So now we actually got to do it. So if we did this, my y's would cancel. And if I put this all together, I'd have negative 5x and 2x. That'd be a total of negative 3x. So negative 3x. And it would be equal to 15. That's a positive 15 here. So 15, take away 15. Well, that's 0. And my last step to solve for x would be to divide both sides by negative 3, and you would get x is equal to 0. So that was relatively straightforward. However, now that we know that x is 0, we could take that information and plug it into one of the equations. You could pick the first one, or the top one, or the bottom one. And I'm looking right here. You could pick either one of these equations. It does not matter. As long as you do your math correctly, whenever you plug in 0 for x, you'll be good. Excuse me. So let's use this top one, only because I know that x is going to be 0, so therefore that's going to end up being 0 here. That'll cancel each other out there. So we have negative 5 x plus 3y equals 15. That's that top equation. And we're going to replace this letter x here with a 0. So negative 5 and then put a 0 plus 3y, and it equals 15. Well, negative 5 times 0 is 0, so that is just a scrub-a-dub-dub. It's all gone. And we have 3y equals 15. Well, that's a one-step equation. We can handle that. Divide both sides by 3, and you get y is equal to 5. And you're all done. So in this case, x is 0 and y is 5. That's a done deal, y'all. That's it. We're all done. That was all 5 problems there. And I'll scroll back through this relatively slowly, so just in case you missed something from your notes, you're welcome to pause it. Excuse me. All right, so that's it. That's all we got. We got 5 problems that we worked out, or at least I worked out for you guys that y'all can watch, and hopefully you learned something from it. If you got any questions, feel free to comment down below. And I'm good with that. So if you guys need anything, just comment down below. Hopefully I can see it. And like, comment, subscribe, dislike, doesn't really matter. Hope y'all have a great day and hope y'all learn something.